Hey there, science fans. Bill Nye here, and today we're diving into the exciting world of clean energy. It's no secret that our planet is facing some serious challenges, and one of the biggest is climate change. We need to find new ways to power our world without relying on fossil fuels, which release harmful greenhouse gases into the atmosphere. That's where renewable energy sources come in. Solar, wind, hydro, and geothermal energy offer clean and sustainable alternatives. These sources tap into the power of nature, harnessing the sun's rays, the wind's force, the flow of water, and the Earth's heat. By shifting towards these clean energy sources, we can reduce our carbon footprint and create a healthier planet for generations to come. But here's the thing about renewable energy: it's not always available when and where we need it. The sun doesn't always shine, the wind doesn't always blow, and that's where energy storage comes in. We need ways to capture and store this clean energy so we can use it even when the sun goes down or the wind dies down. One of the most promising solutions for storing renewable energy is green hydrogen. And how do we make green hydrogen? Through a process called electrolysis. Electrolysis involves using electricity to split water into hydrogen and oxygen. When we use renewable energy to power this process, we get green hydrogen. This green hydrogen can then be used in fuel cells to generate electricity, power vehicles, and even heat our homes. Imagine a future where our cities are powered by clean, renewable energy and our air is free from pollution. Community solar projects and wind farms are already making this vision a reality in many parts of the world. Scientists and engineers are constantly innovating, finding new ways to make renewable energy more efficient and accessible. Educational programs and workshops are also helping to spread awareness and knowledge about the importance of renewable energy. It's up to all of us to take action, whether it's by supporting clean energy initiatives, reducing our own energy consumption, or simply spreading the word. Together, we can create a brighter, more sustainable future for ourselves and for generations to come. So let's get started. So what exactly is electrolysis? In simple terms, it's like using electricity to split water molecules apart. You know that water is made up of hydrogen and oxygen, right? Two hydrogen atoms bonded to one oxygen atom, H2O. Well, electrolysis uses electricity to break those bonds and separate the hydrogen from the oxygen. It's like using a tiny pair of scissors to snip those atoms apart. The result? We get pure hydrogen gas, which can be used as a clean fuel source. Now, you might be wondering why we don't just use hydrogen gas directly, since it's all around us in water. Well, hydrogen is rarely found in its pure form in nature. It's almost always bonded to other elements, like oxygen and water. Electrolysis allows us to isolate hydrogen so we can harness its potential as a fuel. Think of it like this. Electrolysis is like unlocking the energy stored within water molecules. It's a bit like using a key to open a treasure chest filled with clean energy. Let's break down the electrolysis process step by step. Imagine a container filled with water. We insert two electrodes into the water, one positively charged, called the anode, and one negatively charged, called the cathode. When we pass an electric current through the water, something amazing happens. The electricity flows between the electrodes, and this disrupts the bonds holding the hydrogen and oxygen atoms together in water molecules. At the cathode, the negatively charged electrode, water molecules are split, releasing hydrogen gas, H2, and negatively charged hydroxide ions, OH. Meanwhile, at the anode, the positively charged electrode, the hydroxide ions lose electrons, forming oxygen gas, O2, and water. So what started as plain water is now separated into two distinct gases, hydrogen and oxygen. The hydrogen gas can be collected and stored as a clean fuel source, while the oxygen gas is released into the atmosphere. It's like magic, but it's science.
Section 4. Expert Insight. The Promise of Green Hydrogen. Now, I'm not the only one excited about the potential of electrolysis and green hydrogen. I spoke to Dr. Sarah Green, a leading researcher in renewable energy, and she's convinced that this technology is a game changer. Green hydrogen is a crucial piece of the puzzle in our transition to a sustainable energy future, says Dr. Green. It offers a way to store renewable energy on a large scale, addressing the intermittency issues of solar and wind power. This means we can have a reliable and clean energy supply around the clock. Dr. Green emphasizes that unlike hydrogen produced from fossil fuels, which is energy intensive and releases greenhouse gases, green hydrogen is produced using renewable energy sources, making it a truly clean fuel. This technology has the potential to revolutionize various sectors, from transportation to industry, she adds. It's an exciting time to be working in this field.
Section 5. Different types of electrolyzers, alkaline, PEM, and solid oxide. In this section, we will explore the unique characteristics and applications of these three types of electrolyzers, which play a crucial role in the production of green hydrogen. Just like there are different types of cars, there are different types of electrolyzers, each with its own strengths and weaknesses. Understanding these differences is key to selecting the right technology for your specific needs. Let's meet the main players: alkaline, PEM, and solid oxide electrolyzers. Each of these technologies has its own unique way of splitting water molecules to produce hydrogen and oxygen. Alkaline electrolyzers. These are the most mature and commercially available electrolyzers. They have been used for decades and are well known for their reliability and robustness. They've been around for a while and are known for their durability and lower costs. This makes them a popular choice for large-scale industrial applications where cost-effectiveness is a priority. They use a liquid alkaline electrolyte solution like potassium hydroxide to conduct electricity and split water molecules. This process is well understood and has been optimized over many years of use. Proton exchange membrane, PEM, electrolyzers. These are newer kids on the block, known for their efficiency and ability to handle fluctuating power sources like solar and wind. This makes them ideal for integration with renewable energy systems. They use a special proton-conducting membrane to separate the hydrogen and oxygen gases. This membrane is key to their high efficiency and ability to quickly respond to changes in power input. Solid oxide electrolyzers. These high-temperature electrolyzers are still under development but hold great promise for their high efficiency. They operate at temperatures of around 700 to 1000 degrees Celsius. They use a solid ceramic material as the electrolyte, which allows them to operate at elevated temperatures and potentially use heat as an input alongside electricity. This could make them very efficient in certain industrial processes. Each type of electrolyzer has its own set of advantages and disadvantages, and the best choice depends on the specific application and operating conditions. For instance, alkaline electrolyzers are great for large-scale, cost-sensitive projects, while PEM electrolyzers are perfect for renewable energy integration. Solid oxide electrolyzers, though still in development, could revolutionize high-temperature industrial applications with their efficiency. Section 6. Inside electrolyzers. A closer look at the technology. Today, we are diving deep into the heart of electrolyzers to understand the intricate processes that make them so effective in producing hydrogen fuel. Now let's peek inside these electrolyzers and see how they work their magic. These devices are marvels of modern engineering designed to split water molecules into hydrogen and oxygen using electricity. Alkaline electrolyzer. Imagine a tank divided into two compartments by a porous diaphragm. This diaphragm is crucial as it allows ions to pass through while keeping the gases separate. The electrolyte solution, that potassium hydroxide we talked about, fills both compartments. This solution is essential for conducting electricity between the electrodes. When electricity flows through the electrodes, water molecules are split at the cathode, releasing hydrogen gas, which bubbles up and is collected. This process is both efficient and effective in generating hydrogen. Meanwhile, oxygen gas forms at the anode and is collected separately. This separation is vital to ensure the purity of the hydrogen gas produced. PEM electrolyzer. Picture a thin solid membrane sandwiched between two electrodes. This membrane, known as the proton exchange membrane, is a key component in this type of electrolyzer. This membrane acts like a gatekeeper, only allowing protons, positively charged hydrogen ions, to pass through. It ensures that the hydrogen and oxygen gases remain separate. When electricity flows, water molecules at the anode split into protons, electrons, and oxygen gas. This reaction is facilitated by the unique properties of the membrane. The protons travel through the membrane to the cathode, where they combine with electrons to form hydrogen gas. This process is highly efficient and produces high-purity hydrogen. Solid oxide electrolyzer. Envision a solid ceramic cell made up of two electrodes separated by a solid electrolyte. This type of electrolyzer operates at very high temperatures. At high temperatures, water molecules at the cathode react with electrons, producing hydrogen gas and negatively charged oxygen ions. The high temperature increases the efficiency of the reaction. These oxygen ions travel through the solid electrolyte to the anode, where they release their electrons and form oxygen gas. This process is unique to solid oxide electrolyzers and is highly efficient. These are just simplified explanations, but you get the idea. Each type of electrolyzer has its own unique design and operating principles, making them suitable for different applications. Electrolyzers are fascinating devices that use clever designs and materials to split water molecules and produce clean hydrogen fuel. They are a cornerstone of the hydrogen economy, offering a sustainable way to generate energy.